I always time it wrong. Like, it's always you say fractions right before the video. Anyway, standard form, part 2. So yesterday we looked at a lot of different standard form equations that pretty much always worked out perfectly. Like this one, right? We make a t-chart for this and find both the x and y intercept. What we noticed was cover up the x, negative 3y equals 12. So y would be negative 4. Perfect. That worked out as an integer, right? An integer is a whole number that's either positive or negative. And then if we make y 0, we just covered up the y. So x would have been 6. And we were able to graph those pretty quickly by connecting the x and y intercept. But there's lots of different lines, and they're not always going to go through an exact integer on the x or y axis. Sometimes they may go through a decimal, right? They might go through a number that's not an integer, like this. If I had 5x plus 7y equals negative 10. I'm going to do this with the same procedure that we did before. This is kind of the most important thing. I'm not changing anything from what we did yesterday. It's just we're going to have things that don't work out quite as well. So for example, if x is 0, now I have 7y equals negative 10. So what is y?
Negative 1 and negative 2.
Well, here I have to divide by 7, right? So y would be equal to not 10 minus 7, not negative 10 minus 7, but negative 10 divided by 7.
So 1 and 3 is 7.
Yeah. So how are we going to graph this? And there's a couple ways that you could graph it. One, I could find the decimal equivalent. So if on a calculator, if I did 10 divided by 7, I know that this is equal to negative 1.4, and I'm just going to round it, 3. I rounded it. Or I could do it as a mixed number. I know that negative 10 sevenths is equal to negative 1 and 3 sevenths. By taking 7 out of 10. So that's my intercept. That's my y-intercept. I kind of prefer the decimal. I just think it's a little bit cleaner. Okay, and then we have to find the x-intercept. So if y is 0, we have 5x equals 10. So what would x be?
Negative 2.
Yeah, sorry, negative 2. Negative 2. Okay, how do I graph that? Well, it's really basically the same thing we've been doing. The point negative 2, 0 is right here. The point 0, negative 1.43 is just somewhere between 1 and 2, right? It's not quite, like this would be 1.5, halfway. We've got 1.43, so it would be just a little bit before that, right? And then I connect those 2 points with a line. So there's not really a trick here. It's just getting used to or being comfortable with numbers that aren't always integers. Sometimes we might have an irrational number or a fraction, right? A rational number. Let's do a couple more examples like that.
We're estimating pretty much.
What?
We're estimating pretty much on the map.
Yeah, we are. We're estimating exactly where that point is. Because we don't have it labeled. We don't know exactly where 1.43 is. So we're doing our best to put it somewhere close to it. So what if we had something like 6x plus 5y equals 15. Okay? Same procedure. We're going to do the same thing that we did before. X and y make 1 0. X is 0. What's
3.
y? Y is 3. 15 divided by 5. What if y is 0? X would be 15 divided by 6.
It would be 2 and 36.
Okay.
2.5.
2.5. Yeah? What if we did it on the calculator and we said 15 divided by 6, 2.5? Is that the same thing as 2.5? Yeah. Right? So either way you want to think of it, either as 2.5 or as 2.5. I tend to prefer the decimal version, like I said. But there's really no difference. It doesn't make a difference. As long as you can find where that number is on the x-axis. So 0, 3 is going to be right here. And then 2.50, well, 2.5 is exactly halfway between 2 and 3. So that point would be right here in the middle. Does that make sense? 2.5. Boom. Connect those with a straight line. A couple other things I wanted to go over. So there was one like this on the homework last night. But we didn't actually go over it, I don't think, in class. Yeah, so in this case, what's a little different about this one than the ones that we've done as previous examples?
They don't have a number, but there's a number.
Yeah,
that is 1.
there is no coefficient, so in other words, the coefficient is 1. So if x is 0, what would y be?
4.
4. It's actually really simple in a way, right? Because we're just dividing by 1. If y is 0, x would be 4. 1, 2, 3, 4. 1, 2, 3, 4. Connect them with a line. Right? So if there's no number in front of the x or y, we just immediately have our answer. Y equals 4, x equals 4. But what if we had something like this? Negative x minus y equals.
It would just be -1.
Yeah, so we can think of those negatives as negative 1x or negative 1y. So what are we going to end up with? If x is 0, negative y is 3, so y would be negative 3. If y is 0, negative x is 3, so x would be negative 3. What we're doing really is we're dividing by negative 1 so that we can find that x equals negative 3. Right? Sort of another way of thinking about this is negative x is the same thing as negative 1x. So we divide off the negative 1. And we could graph that one. Yeah. Positive slope or negative slope? Negative. We could actually find the slope of this. If you think about it, the slope is rise over run, right? So to get from this point to this point, we went down 1, 2, 3, over 1, 2, 3. So the slope is negative 3 over 3, or negative 1. The slope of that line is negative 1. Do you guys remember we did that? Counting from one point to the next. Alright. What about if I had something like this? 3x plus just forgot what I was going to do.
3x plus 4x.
Well, I think what I was going to do is actually what we're doing tomorrow. So we're going to save that one. Yeah, we'll save it. What if I just had this? Y equals 5. Is that standard form? Are x and y on the same side? It's kind of hard to tell because there is no x. The answer to this technically is that this is in standard form.
Yeah, because
It's just that it's 0x. But we actually already learned how to graph these. If y equals 5, we just remembered that if y equals 5, y always has to be 5. No matter what x is, y is 5. X could be over here, y would still be 5. X could be way over here, y would still be 5. If y equals 5 and we're graphing that as a line, it doesn't matter what x is. The y is stuck at 5. So it's a line going across like this. Alright? And then this technically is also standard form. X equals negative 2. And y doesn't figure into this equation. So if x is equal to negative 2, here's where x is negative 2. And it doesn't matter what y is, x will always be negative 2. No matter what value of y I choose. So x equals negative 2 is a line like that. Right? So when you see that y equals, you're thinking of a horizontal line. And x equals, you're thinking of a vertical. Now what if I had x equals 0? X equals 0. What would that look like? Where would it be?
Straight up on the line.
Ah, right? X is 0 right here. And it doesn't matter what y is, x always has to be 0. In other words, actually, let me get a different colored marker. In other words, x equals 0 is the equation of the y-axis. The y-axis is a line, right? It's a straight up and down line, and it is the line x equals 0. So this is sort of a weird one, it seems like at first, but it's really the same as those other ones we did. X always has to be 0. Y can be anything. Y could be 17 or 25 or negative 2,564, and x would still be 0 because x is always 0. So that's the equation of the y-axis. What do you think would be the equation of the x-axis? That one. Y equals 0 is the equation of the x-axis. Yeah. That's exactly right. It's kind of weird to think that x-axis is y equals 0 and the y-axis is x equals 0. But it makes sense too because the y-axis, y is always changing, and the x-axis, x is always changing. And actually, if you think about it, we kind of already knew that. Because the y-intercept, the point where a line hits the y-axis, right, is where x is 0. The y-intercept is always where x is 0. So the y-axis is where x is 0. The x-intercept is always where y is 0. That's where the line will hit the x-axis. So in a way, we kind of already knew that. And that's based on how we graph standard form. All right, that's it for today.